Hello everybody, welcome to the I Am IT YouTube channel. My name is Shabazz and as ever, I am the IT Geek. We are back with another video in the SE100 kind of exam topic series. We are still on topic 11, so hopefully within the next month we'll be finishing this whole series. So I'll try and plow through these episodes if we can. So um, as I mentioned, this is the Microsoft Cybersecurity Architect exam topic series, which is SE100. So this is topic 11 part 2. So this is a 3-part topic, I think. So it's 3 parts to this topic 11. So this topic, just a reminder, is about designing solutions for securing organizations' data. And in this video today, we're going to talk about designing a solution for protection of data at rest, data in motion, and data in use. I'm going to talk about data security in Azure workloads, and then I'm going to go back into the Purview and look at some sensitivity labels in the demo. So let's talk about designing a solution for protection of data at rest, data in motion, and data in use. So first of all, we talked a little bit about data in transit and data at rest in the last episode. Kind of introduced it. So data in transit should be encrypted at sort of all points to ensure that data integrity. Protecting data in transit should be sort of essential part of your data protection strategy, because data is moving back and forth from many locations. Microsoft generally recommend that you always use SSL TLS protocols to exchange data across different locations. For data moving between your on-premises infrastructure and Azure, you can consider sort of appropriate safeguards such as HTTPS or VPN. When sending encrypted traffic between Azure virtual networks and on-premises locations over public internet, you can use Azure VPN Gateway or ExpressRoute, obviously. Sort of questions we need to ask ourselves: does the workload communicate over encrypted network traffic only? Any network communication between the client and server where man-in-the-middle attacks can occur must be encrypted. All website communication should use HTTPS, no matter the perceived sort of sensitivity of the transferred data. And then man-in-the-middle attacks can occur anywhere on the site, not just sort of login forms. This mechanism can be applied to multiple different use cases, such as web applications and APIs for all communication clients, or communications with clients. Any data moving across service bus from on-premises to the cloud and the other way around as well, or sort of during input-output process. All data should be encrypted in transit using that common encryption standard. If all components in that solution are using consistent standards, then it's obviously better. There are times when encryption is not possible because of sort of technical limitations, so make sure that reason is clear and sort of valid. So I want to move on now to talking about data protection at rest. So something to note: data at rest encrypted is encrypted by default in Azure. So that's one thing to note. And data at rest is encrypted by default in Azure, which makes life a lot easier, obviously. And but this is critical data classified and tagged, all labeled so it can be so it can be audited. Your most sensitive data might include business, financial, healthcare, or personal information. Discovering and classifying this data can play a pivotal role in your organization's protection approach, and it can serve as sort of your infrastructure for helping to meet standards for data privacy and requirements for regulatory compliance. Various security scenarios as well, such as monitoring, auditing, and alerting on anomalous access to that sensitive data. It can serve as infrastructure for controlling access to and hardening the security of your sort of databases that contain highly sensitive information as well. Some suggested actions, include classifying your data, so consider using that sort of data discovery and classification. And it's crucial. The crucial sort of initial exercise for protecting data is to organise it into categories based on certain sort of criteria. So these classification criteria can be sort of business needs, compliance requirements, and the type of data. And depending on that category, you can protect it through either standard encryption mechanisms or enforcing security governance through policies, or conducting audits to make sure the security measures are sort of compliant. And obviously one way of classifying is by using tags. So let's talk about data security in Azure workloads specifically. Again, we touched on this in the last video, so I'm going to a bit more detail now. Let's talk about network security first. So Microsoft Azure SQL databases. So we talk about the SQL's database SQL, Azure SQL specifically, network access and network and access management. So Microsoft Azure SQL databases, Microsoft SQL managed instances, and Azure Synapse Analytics provide a relational database service for cloud enterprise applications. And to help protect customer data, firewalls prevent network access to the server until access is explicitly granted based on sort of IP address or Azure Virtual Network traffic origin. You also have IP firewall rules, so these rules grant access to databases based on originating IP address of each request. There's also virtual network firewall rules, so the virtual network service endpoints extend your virtual network connectivity over that sort of Azure backbone and enable Azure SQL databases to identify the virtual network subnet that traffic originates from. To allow traffic to reach Azure SQL databases, you can use the SQL service tags to allow outbound traffic through NSGs. There's then the virtual network rules as well, so you enable SQL databases to only accept communications that are sent from selected subnets inside your virtual network. From an authentication perspective, authentication is the process of providing the user who they claim to be. Azure SQL databases and SQL managed instances support SQL authentication and Microsoft Entra authentication. SQL managed instances additionally support Windows authentication for Microsoft Entra principles. From a SQL authentication perspective, SQL authentication refers to that authentication of a user when connecting to Azure SQL databases or Azure SQL managed instances using username and password. A server admin sign in with a username and password must be specified when the server is being created. Using these credentials, a server admin can authenticate to any database on that server or instance as the database owner. After that, other SQL sort of logins and users can be created by the server admin, which enable users to connect using that specific username and password. We then got Microsoft Entra authentication. So Microsoft Entra authentication is that mechanism of connecting to Azure SQL databases, Azure SQL managed instances, and Azure Synapse Analytics by using identities in Microsoft Entra ID. The Entra authentication allows administrators to centrally manage the identities and permissions of databases using users along with other Azure services in one central location. Again, this includes sort of the minimization of password storage and enables central password rotation policies. Then got the Windows authentication for Microsoft Entra principles as well. So Kerberos authentication for Microsoft Entra principles enables Windows authentication for Azure SQL managed instances. The Windows authentication for managed instances empowers customers to move sort of existing services to the cloud while maintaining a seamless sort of user experience and provides that basis for the infrastructure modernization as well. So we'll talk about authorization now quickly before I move on to the final sort of slide. So authorization refers to controlling access on resources and sort of commands with a database. This is done by assigning permissions to a user within a database in Azure SQL databases or Azure SQL managed instances. Permissions are ideally managed by adding user accounts to sort of database roles and assigning database level permissions to those roles as well. Alternatively, an individual user can also be granted certain object level permissions. Then we have row level security as well. So row level security enables customers to control access to rows in a database table based on certain characteristics of the user executing a query, for example, group membership or execution context. Row level security can also be used to implement custom label-based concepts as well. So, last few things I want to talk about before I move into the demo, threat protection and information protection and encryption. So, SQL database and SQL managed instances secure customer data by providing auditing and threat detection capabilities. First, we have SQL auditing in Azure Monitor Logs and Event Hubs. So, SQL database and SQL managed instances auditing tracks database activities and helps maintain compliance with security standards by recording database events to an audit log in the custom-owned Azure storage account. Auditing is going to allow users to monitor ongoing database activities as well as analyze and investigate historical activity to identify potential threats or suspected abuse and security violations. We have advanced threat protection as well. So this is analysing your logs to detect unusual behaviour and potentially harmful attempts to access or exploit databases. Alerts can be created for suspicious activities such as SQL injection, potential data infiltration, and brute force attacks, or for anomalies sort of in access patterns to catch privileges escalation and breached credential use. And alerts are viewed from Microsoft Defender for Cloud, where the details of the suspicious activities are provided and then further recommendations are also given. Then got information protection and encryption, so you can use the transport layer security, so encryption in transit essentially. So SQL database, SQL management and Azure Synapse Analytics secure customer data by encrypting data in motion with TLS, transport layer security. They also enforce encryption as well, SSL, TLS, at all times for all connections. They have transparent data encryption, so it's encryption at rest. So for SQL databases, for SQL Managed Instance, and for Synapse Analytics, Azure Synapse Analytics as well, it adds a layer of security to help protect data at rest from sort of unauthorized or offline access to raw files and backups. Common scenarios include sort of data center theft or unsecure disposal of hardware or media such as disks and sort of backup tapes. Finally, we have the sort of key. Well, sorry, not finally, but we have key management for with Azure Key Vault. So you've got BYOK, which is bring your own key, and this supports the transparent data encryption or TD, and it allows customers to make ownership of key management and rotation using Azure Key Vault. Azure's cloud-based external sort of key management system is Key Vault, and if a database is access to keys is revoked, the database cannot be decrypted and read into memory. Azure Key Vault provides that sort of central management platform and leverages tightly monitored hardware security modules as well, HSMs, and enables separation of duties between management of keys and data to help meet sort of security compliance requirements. 3, 2, 1. We then have Always Encrypted, which is a feature designed to help protect sensitive data that's stored in specific database columns for access. Example, credit card numbers, national regional identification numbers, or data on a sort of need-to-know basis. And this includes database administrators or any privileged sort of users who have authorized to access the database to perform these sort of management tasks, but have no business need to access the particular data in the encrypted columns themselves. Finally, we have dynamic data masking, and this limits sensitive data exposure by masking it for non-privileged users. It automatically discovers potentially sensitive data in Azure SQL databases and SQL managed instances, and provides actionable recommendations as well to mask those fields with minimum impact to the application layer itself. And it works by obfuscating, if that's the way you pronounce it, obfuscating the sensitive data in a result of a set of query over sort of designated database fields, while the data in the database is not changed. So a lot of information to take there. So we're going to jump back into the Purview portal. We're going to look at sensitive labels and sensitivity label policies as well. So please join me in the demo. Well, welcome back. We're in the demo portal again. I want to look at information protection in Purview, specifically sensitivity labels. So here, as you can see, we can extend labeling beyond M365. So it's turned on, and we can apply these to non-Microsoft like Azure and Azure and Amazon S3. So we can simply turn that on, and that data map will then start looking at other sources as well. Here we can see we've got sensitivity labels, and they're used to classify email messages, document sites, and more. So I've got a couple already set up, but let's just kind of create one here. Let's call it C100 demo. Call it the same name. So look at some of the options that we've got for sensitivity labels. So you give it a priority, depending on what priority you want. Description for users. This is an SC-100 demo label. And again, if you're really picky, you can choose a color for the label. Again, if you have multiple labels, I'd recommend doing a color coordination. So here's where we can define the scope now. So where do we want these labels to be applied directly to? So we've got items, or which items? So do we want to protect files in Word, Excel, PowerPoint, or emails? Again, a lot of the time you're gonna, in my kind of experience, you're gonna have both of these enabled really. Because a lot of times it's the Office suite really. So you want to protect your files, your Word, Excel, PowerPoint, stuff like that. You want to protect your emails as well, because normally that's how you can send those files when you want to send them. Again, this is in preview at the moment, but schematized data assets. So this is applying it to things like SQL, Azure SQL. I've not had any use cases in my sort of day-to-day life or day-to-day work where this has been a requirement. But as we can choose a protection setting, so we can have control access or apply content markings. So when you control access, you control who can access and view labeled items. Or if you want to apply any content markings, you can. So this will add like sort of custom headers, footers, and watermarks to labeled items. Again, I've seen examples of both these being used, or just always control access is normally enabled, but it's up to you whether you want to apply content markings or not. For the purpose of demo, we won't. So here we can configure those access controls. So assign permissions now, or do you want to let the users decide? So again, we've got permission, options that we can let the users assign permissions when they apply the label. I think that's probably the better requirement. Depends what the use case is, but when you want to empower users, you make sure they have the correct training. But when you empower users to apply these labels, you need to give them the options who can actually access it. Give them that responsibility. Here in Outlook, you can enforce either do not forward or encrypt only. So again, depends what your use case is. And then in Word and PowerPoint, Excel, you can prompt users to specify permissions as well. So I'm a big fan of empowering users and giving them that responsibility. Auto labeling as well, I'm a big fan of. So again, you can set that sort of auto labeling content. You can detect content that matches certain criteria, and then again, when the content matches, what do you want to do? Automatically apply, or recommend that users apply. I would recommend enforcing it, so automatically applying it. Again, recommending it just means you're giving users an out and a way of not doing it. And then display a message when the label is applied as well. And here you can define protection settings for groups and websites as well. And these settings apply to teams and sites that labels apply to. And finally, that'll set it up. So that was just a quick demo on sort of sensitivity labeling, some of the settings, and there's different scopes that they can be applied to. Again, this is just a way of protecting information within Office 365. So hopefully this is helping you guys with your preparation. Please do drop me a comment. I have loads of positive feedback, and I always appreciate positive feedback, or even any constructive feedback about how you want me to improve my videos. I'm always welcome to new ideas. So yeah, so loads of useful links in the description. Link to the GitHub repository where the case studies are. Also a link to Measure Up and their sort of practice exam, which I recommend purchasing. I think it's got a discount on it, so you can use that link. But also a link to the Microsoft Learn content as well is going to help you as well for the SE100 exam. So thank you for watching, and until next time, goodbye.